Hannah, Iris, Jacob, and Kim have playoff tickets for a hockey game in the adjacent seats A3 to A8. How many different ways can they sit together? So we have A3, A4, A5, A6, A7, A8. Is there any restrictions on seating? No. So how many do we have here? Then, which we can write as 6 factorial. What else can we write it as? Do you remember? 6 P, how many? 6. Remember, the first number is how many options you have. The second one behind the P is how many blanks. And it only works if you're going down by 1 each, right? Okay, George and Hannah are dating. And how many arrangements could they sit together? You try that one out. George and Hannah sitting together. Okay, so here it says George and Hannah are dating, and how many arrangements would they be sitting together? It doesn't say George on the left, Hannah on the right. If it did say that, it'd be 1, 1. It just says they have to be together, correct? Does it say together on the far left? No. If it said together on the far left, we would just do 1, 2, 3, 4, 5, 6. Hook them together. I have 2 options for this one. It could be George or Hannah. I say sit down, one of them, and then I get the next one. Then I've sat down George and Hannah. Now I have 4, 3, 2, 1. If I said George and Hannah had to sit on the far left, poof, we'd be done. Answer. Correct? But it didn't say that. It said that George and Hannah have to sit together. So we have to move them still. There's all those places that they could sit together, correct? And it's going to be multiplied by 5. It's always 1 more than the number after the hooked together numbers. If you forget that, not a big deal. Start counting. I pressed red. 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5 they could be, and that's how we multiply by 5. But it's always 1 more than the hooked together numbers. You don't have to overthink it. So if they want to write this in something simpler, they could go 2 times 1, which is just 2, or you could do 2 factorial, but that's just 2, times 4, 3, 2, 1 times 5. What is that? That's 5, 4, 3, 2, 1. Blast off. I know it's out of order, but because the commutative property of multiplication, you can put anything in any order, like 2 times 3, and 3 times 2. Do fact families in elementary school. Why do I know that? Because my kids are in elementary school, and I didn't know anything was called a fact family, but now I am like elementary literate. Fact families. So 3 times 2, 2 times 3, 5, 4, 3, 2, 1, 5 factorial. Okay? Great thing is it always turns out to something nice because it is always 1 more than this number, correct? So this is a 4, and this is a 5. 5, 4, 3, 2, 1. 5 factorial, right? It always works out to a nice number because it can join those ones because 1 more. So you get 240. So, fun fact. These 5 people sitting together, there's a maximum of 700, and by 5 I mean 6. These 6 people sitting together have a maximum of 720 ways you could rearrange them all over, and they form a different seating pattern, correct? Of those 720 ways, there are 240 where George and Hannah can sit together, right? 240 of them, of the 720, where they are sitting together. Then C says, just before the game, George and Hannah have a disagreement and decide not to sit together. How many ways can this happen? Well, if there's 240 ways they can sit together out of 720, what could I do to find out all the ways they can't? Just subtract them, right? I take the total no restrictions, which we know is 6 factorial or 720, and then I actually subtract off George and Hannah sitting together, all the ways they can sit together, because then I'll have the leftovers. And then what's left over are George and Hannah not sitting together, because it took off all the cases where they do. What's 720 minus 240?
40.
Yeah. So I take all the cases max, take all the cases opposite together, and the opposite sitting together is not sitting together, so I get all the rest of the cases left over. Okay? Or flip over. So, I want you to try this one out. Example 6, we have the word Canada. What's the very first thing we're going to have to do, though? Write it out. C-A-N-A-D-A. Why am I writing this so stupid? Is it fun trying to think stupid? No. Why am I writing it out like this? Yeah.
So you know how many letters you're doing.
Yeah. So I'm going to do this. I'm not even reading the question. I'm a rebel. Rebel without a cause here. The moment I have tripling letters, I have 3 factorial denominator. And why am I doing that? Because I'm getting rid of all the cases where the A's actually would be the same. Okay? Try them out. I would try and draw those straight. I kind of got a little crazy. Canada has 6 letters. So on the top we're going to have 6. 1, 2, 3, 4, 5, 6. There's restrictions, we have to deal with them. First, it said it must begin with a vowel. There are 3 vowels in Canada. Yes, they're the same vowels. I don't care. The 3 factorial gets rid of the situation where they actually look the same, right? So we always treat them like you can tell the difference. So we have 3 options here, A, or A, and then we leave an A there, right? Then it has to end in a consonant. There are 3 consonants. Now in each blank, how many letters am I leaving behind? 1 and 1. So how many have I left behind? 2. So how many do I have left for here? 4, 3, 2, 1. And how much does this work out to? 216. Then this one says, must begin with C and D in that order. Yep.
216 is like the top. That's before you divide it by 3.
Perfect. Cool. I like that. We'll box this too, because why not? What do we get?
36.
36. Much nicer answer. You know, it's 3 times 2 is 6, 2 digits. It's got a 3 and a 6 in it. It's 9, which is also a multiple of 3 and 6. So many good things with 3 and 6. Although my favorite number is 4, which has nothing to do with that. Must begin with C and D. Begin with it in that order. You have to watch yourself when it says begin, because people will be so used to, I have drilled into your heads, you have to move it because it's together, that you move it, but it says begin, so we're not moving it. So, it begins with C and D in that order. 1, 1, 1. Then I have 3, 2, 1. Do I move those? No, it says begin, right? So it's actually just 1. There's one way. Which makes sense. You go C and D, A. Switch those A's around. It doesn't make a diddly squat difference. I get 1 off. The next one says C and D must be together, but in that order, but now together. So I'm going to have some movement with it. So 1, 2, 3, 4, 5, 6. I have 1, 1, 1, but they must be together in that order. So it's C and D again. Then I have 3, 2, 1. But this time it doesn't say begin. It says has to be together. So I'm going to multiply it by the 4 spots I can move it. 1, 2, 3, 4. It's always 1 more than the number after the hooked together numbers. So it's going to be 24 divided by 6, which is 4. And this one says C and D must be together in any order. So this is where I can put C and D, either of them first, right? So 1, 2, 3, 4, 5, 6. I could have C and D here, which is 3. Then I hold one of them, 2. Then I hold the next one, 1. Then I've used up 3 letters, so I have 3, 2, 1 left. And I would be done if it said together at the front, right? But it just says together, so what do I have to multiply by? 4. Because there's 4 places it can move. 1, 2, 3, 4. So I have to multiply by 4, which is 24. Okay. Here, Julie's home is 3 blocks north and 5 blocks west of her school. So I'm going to draw her school down here because I need to go north and west. So it's 3 blocks north. 1, 2, 3. And then 5 blocks west. 1, 2, 3, 4, 5. And then I just connect them and make a box. Because there's a whole bunch of pathways you could take if they were all perfectly square. Different pathways you could take to get from the school to home, right? Like you could walk all the way along. You could head, instead of going up 3 north and then 5 blocks west, you could go up 1 north, 5 blocks west, up 2 north. Like you have all those different paths you could take, right? So here it says, how many routes can Julie take from home to school if she always travels either south or east? Everyone put down your pencils because I absolutely do not want you to do it this way. This is just proving that I get the same answer. Okay? In the old 30 applied curriculum, we used to do pathways, and you have to be able to calculate pathways. But this is in the perms and comms questions for a reason. We have to be able to use perms or comms or fundamental accounting principle or something, right? So I'm proving to you that you actually get the same answer that I'm going to get when I use fundamental accounting principle. Okay? But I don't want you to ever do it this way. It's not actually in the curriculum this way, so don't let it overwhelm you. It's just to prove that I'm not lying to you and telling you to do something miraculous to get the right answer. So the way you can do pathways is you can count 1 to here, you have 1 path to there, you have 1 path to there, you could just walk to it. You have 1 path to here, you could just walk to it. You have 1 path to here, you could just walk to it. Because we're not allowed to circle back, or else it would be an infinite number. Then I have 1 to here, I could walk to it, 1 to here, I could walk to it, 1 to here, I could walk to it. Then with the pathway rules, you just actually add the number of paths along the way. You're like summing them up as you go along. So if I have 1 path coming in from here, and I have 1 path coming in from here, that's a total of 2 paths that could get me here, right? And if I had 2 paths coming in from here and 1 path coming in from here, then I would have 3 paths. 3 and 1, 4, 4 and 1, 5, a total, 5 and 1, a total of 6 paths that could get me here. Then I have 1 and 2, so I have a total of 3 paths to get me here. 3 and 3, total of 6. 6 and 4, total of 10. I'm doing this fast because I don't want you to do it this way. 10 and 5 is 15. 15 and 6 is 21. Then I have 1 and 3, so 4. 4 and 6, 10. 10 and 10, 20. 20 and 15, 35. And then 35 and 21 is 56. So I'm telling you there's 56 ways, right, if I just count all my paths. We agree? So why is this in perms and comms? Well, because I can treat it like the word der. Ready? And not ready. Okay. Duh. I pressed green. It shows green. It writes red. Duh for 3 downs and for rights. Sure. This you can write. It's very educational. The word der. So all you have to do is count all the downs and all the rights. Okay? And now we have the word der. If I were to write out the word der, I would write it stacked, like Canada, the 3 8s, correct? This would be my word. So this is the word der, but written in my stacking form. Der. So now if I said rearrange the word der, how many ways could that happen? Well, you would know in the denominator you would need a 3 factorial and a 5 factorial, correct? Because you have 3 D's and 5 R's in brackets. Always, so that we make sure we divide by the whole denominator if we're not using fraction buttons. In the top, you would have, make sure you're paying attention, in the top you would have all the ways you could rearrange der. How many letters are in der? Not different letters. How many letters are there in der? 8. There are 8. your statement. Yes, 8. Okay? So on the top, I could go 8 factorial. Why can I do 8 factorial? Because if I was rearranging dir, I would treat them the top like they're all different, correct? So I would have 8, hold 1, 7, 6, 5, 4, 3, 2, 1, done. Right? So type that into your calculator. What are we getting for an answer? It's like the light. This is like light bulb moment. It's fantastic. What do we get? 50. Oh, it's the same. It does work. It's real. I didn't just make something up. I proved it with a picture. All right, cool. Ah, there's more. There's more. What do we do? Nothing different. We literally treat it like it's 2 words. They're just der and then d, you know, like d, and then d, you know. So this one says, a supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall. Determine the number of routes possible if the bus must always move closer to the concert hall. They're just saying that you can't loop. If you could loop, it'd be an infinite number of routes, right? They're just stopping the infinite option. So what I want you to do is I want you to find how you'd rearrange the word der, and then find how you rearrange the other word der. You know, they're very different. So you find out the 2. Are we going to add the 2 answers, or are we going to multiply them? Do we need this path and this path to get us there? Or could we just fly through time and do this path or this path and completely bypass the other ones? It's an and, so we're going to have to multiply. And the other hint is I always say put a dot between these, like a really big dot, and that hints to you that you have to multiply the 2 answers. Okay? So find out both answers and multiply them, see how you do. This green one, I would get 7 factorial divided by 3 factorial. That's a lie. I'm going to do 4 first. Why did I? It doesn't matter. I could have done 3, but I want to do the bigger one. 4 factorial, 3 factorial. What do we get for this answer? 35. And then this one is 5 factorial divided by 2 factorial, 3 factorial. What do we get for this one? 10. And then what do we do with them? Multiply. What does it say at the top of the next page? Your turn. Your turn, your turn, your turn, your turn, your turn, your turn, your turn. That's what you have left for the rest of the class.